All right. First quadrilateral we'll talk about is a trapezoid, and the definition of a trapezoid is a quadrilateral having at least one pair of parallel sides. Okay? Those parallel sides are actually called the bases. And so a trapezoid has two bases because it has two sides that are parallel to each other. Okay? In a trapezoid, consecutive angles between the parallel sides are supplementary, which means that they add up to equal 180 degrees. So remember when we talk about parallel lines cut by a transversal, that's kind of where that comes from. There's your parallel lines, and here comes the transversal. If we think about this angle here, this angle here and this angle here, those would be supplementary, okay, because those are same side interior angles. Okay, and the same thing happens on the other side between the parallel lines, but using the other side as a transversal, these two angles here also add up to equal 180 degrees. Okay, so if you know one, you know the other one. Okay, these add up to 180 as well. Okay, so in number one, they're asking us to draw a trapezoid. So we always draw a trapezoid with a short top, a longer bottom, maybe on one side, connected and connected. And we could put our markings in there that's those two sides are parallel. Okay? And it's hard to label trapezoids sometimes because they only have the one pair of parallel. It says that TR is parallel to AP. So one of my sides has to be TR, and then the other side has to be AP. But remember that you have to go consecutively either clockwise or counterclockwise in order to label. So my A actually has to be there, and then my P here. So it's TRAP. TR is parallel to AP. And so now we can go ahead and fill in that their angle A is 82 degrees. They want you to find all other angles possible. Well, we could actually only find one because this is only a trapezoid. We only know that these two angles add up to equal 180 degrees. And so there are only 98 degrees left for angle R. Okay? We don't know what these other ones are. If we knew one of them, we could fill in the other, but we don't know how to split 180 between those two angles. They could be anything. They have no relationship between what angle R and angle A are over here. So that's the only one we can find. We could just say angle R is equal to 98 degrees. And that's it. Okay, let's see what the next one. Okay, there's something called a median of a trapezoid. It's also called a mid-segment, and that's this line right here in the middle. And they call it a mid-segment because this point right here is the midpoint of this side. And this is also a midpoint, okay, of the other side. And when you connect them, you get what they call a mid-segment or a median, okay? It's a segment that connects the midpoint of one leg to the midpoint of the other leg. Okay? The median or mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases, which sounds very complicated, but it actually is very easy. If you average the base lengths, that equals the median. And all you do in an average, if you think about how you take an average of your grades, if you ever averaged your grades together, you take the two grades, like two test grades, and you add them together. And because you added two things together, you divide by 1/2, or you take half of it. Okay? Sometimes I like to write it like this instead. I average by adding two things together, and then I divide by 2. And that's the length of the median. It's smack dab right in between the two lengths of the bases. Okay. All right. Definition of an isosceles trapezoid. Isosceles is the new word. It's a trapezoid with congruent diagonals. So if we were to draw in one of its diagonal and the other one and we were to measure them, those two red line segments would be equal in length. So it has congruent diagonals. The bases are still parallel. So the top base is still parallel with the bottom base. What they call the non-base sides. This here is a non-base side, and this here is a non-base side. They're also called the legs, and they are congruent. They have the same length, so we can tick mark them. Okay. The diagonals are congruent, which we already talked about up in the definition. And then one more thing, it has two pairs of base angles that are congruent. So down here, this is a base, and this is a base up here. So these two angles that sit on the bottom base are equal, and these two angles that sit up at the top base are also equal. All right. Remember that these two sides are called legs or non-base sides or non-parallel sides. So you got two bases and two legs. All right, in number 2 here, it says that isosceles trapezoid ABCD with bases AB and CD, so we know that those are the parallels. They also said that it's isosceles, so we could go ahead and put our markings in. We know that it has two pairs of base angles that are equal. We also know that these two sides, called the non-base sides, have the same length. And then they go ahead and they give us some numbers. They tell us that BC is 27 and that angle A is 83. And they want you to find as many other lengths and angle measures as possible. So based on our markings, that 83 can be carried over here. So it has an equal pair of base angles on the base AB. We could take the 27 and put it over here so that the non-base sides or the legs are congruent. And then we have to remember something that happened in the trapezoid, that because these lines here or bases here are parallel, and this side here or the leg acts as the transversal, that these two angles add up to equal 180 degrees. And so if one of them is 83, then these two angles down here have to be 97. Okay. And then we have our filled in trapezoid, and that is all we can fill in. Okay. We cannot figure out the lengths of the two bases or the two parallel sides. It's the only thing we don't have filled in. Okay. All right. Number 3. It says in the accompanied diagram, it's an isosceles trapezoid, so that's good. Okay. We could go ahead and mark it so that we remember that it's an isosceles trapezoid in case they ask us about any of those angles or sides. They said it has a base of length 6 on the top there and 12 on the bottom, and an altitude of length 4. So you can see that they drew the altitude in with this nice dashed line. It goes perpendicular to the other side, and I know it's perpendicular because there's a right angle box in there. And they want you to find the length of CD. So if you notice, what we have is a tiny right triangle right here with an unknown hypotenuse. And I know that anytime they're asking about an unknown side of a right triangle, sides of a right triangle have to work in the Pythagorean theorem. So I'm wondering if we could figure out the other two sides of our right triangle, we could throw those two sides into the Pythagorean theorem and figure out the length of CD, which is the hypotenuse of that right triangle. And if you remember, they did tell you one thing in the reading that wasn't in there is that the altitude has a length of 4. And so this is 4 here. So one of our letters has to be 4. But we're still stuck here because we don't know everything about this right triangle yet. We know we don't know that. We know this is 4, but we also need to figure out what's down here on the bottom. And so what we're going to do is isosceles trapezoids are very symmetrical. So what we're going to be doing is we're going to draw in an altitude on the other side. Okay. And we're going to make a nice little rectangle here in the middle. And we're going to take that 6 on top of the rectangle. Not that we know a lot about rectangles yet. And we're going to bring that 6 down. And so the whole base on the bottom still has to be 12. And if you think about it, if there's 6 in the middle, I still have 6 to split equally on the ends, because remember, we said an isosceles trapezoid is symmetrical. And so if we put a 3 here and a 3 here, 3 plus 6 plus 3 still equals 12. But we got that nice 6 in the middle, and we got the 3s on each side. And so now we know that this has to be 3. And so we're going to go finish our Pythagorean theorem off with a 4 squared plus 3 squared equals our hypotenuse squared. Okay, this is 16 plus 9 equal to c squared. 25 equals c squared. Take the square root. The square root and the square cancel each other out, leaving you with c. And the square root of 25 is a nice old 5. And now we have figured out that CD is 5, which also means that EF is 5. Okay, because it's an isosceles trapezoid, those two non-base sides or leg sides have to be equal. And we figured out what the length of CD is. CD equals 5. All right, we'll see you for one more problem on the next page.